Hey everybody, this is Larry. This is me trying to do an extra problem after the daily problem because I've done enough of the daily problems. So let's take a look at one that I haven't done yet. Computer taking a long time to load. Okay, let's do an RNG one. Let's go. 16 1612. Check if two expression trees are equivalent. A binary expression tree is a kind of and I have trouble reading today. The kind of binary tree representing arithmetic expressions. Each node. Okay. What is Q1? I don't know what Q1 is. Okay, but fine. Huh. Oh, it's only addition? Is that? Oh. Let's think about this for a second. This is an interest, or it's one that I have to think about a little bit. I mean, subtraction makes it a lot complicated for sure. But, or I haven't even, let's not even think about that yet. For addition, so the thing about addition is that is both distributive and commutative, right? Um, okay, yeah. I was reading to see what what they consider equivalent, but they evaluate the same value. And I think the idea here with addition is that, like I said, it's commutative and distributive. So that means that if you have the same number of um, if you have the same number of variables for each one, that should be fine. So then the idea here is just to do a traversal of tree one and then tree two, and then see if they just have the same number of variables, right? And that should be good. We'll think about the subtraction one afterwards, though it's not clear. No, I mean I think that should be fine too. We'll talk about it in a sec. Let's do it. Right. Yeah, let's just put in the counter. I think maybe. Just keep it a little bit easier. Otherwise, you have to kind of return counters all over the place if you want to, which is a little bit awkward. Right, so we traverse root one. Let's say counter one is equal to two. Right, so then we just return counter one, and that should be good. Right, let's give it a submit. Yeah, pretty straightforward. Once you kind of boil down the implications, and like I said, with addition, it is both commutative and distributive, so you should be fine. And then the bonus question, if you will, is subtraction, right? Well, subtraction is not that bad actually. I mean, it's definitely more complicated, but it just means that instead of adding for each of the things, you just have to invert everything in that subtree, right? Meaning you're subtracting everything in that subtree. At least on the right side. I mean, yeah. So you have like you have a negative, then a minus b. So then you would just negate everything on the right side, and then kind of do that recursively, and then just aggregate them as the same way that we have here, except for that you just kind of do the negative versions. Curious whether there is a follow up on this. Would like to do that too while I'm here. But maybe not. I mean, I don't know. But yeah, overall, I mean, this is going to be linear time, linear space. It's just two traversals of two trees. It's pretty straightforward in implementation, but I think definitely you have to kind of, be familiar and confident with the math to get it quickly. But yeah, don't really have much to add to this one. I mean, I think maybe I use too many mathematical terms, like commutative is just a plus b is equal to b plus a, and distributive is to prevent things that you see here, like, well, this one's a little bit awkward more. Actually, that's not distributive. That's just a little, that is commutative actually. So it just means a plus b plus c is equal to A plus B plus C, right? Like the parens you can do. Yeah. Hope I'm right on that one. But yeah, that's all I have for this one. Let me know what you think. And yeah, stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.